Are we live?
And we're live.
Oh, there was no countdown. So, hello, Ivar. Ivar is right, or Ivar?
Ivar, but either way, I answer both.
So now the most important question: where is your Duke tattoo?
Sorry, where's my Duke tattoo? Oh, my Duke tattoo is here on my arm. Of course, yeah, it's
okay.
Hard to get. Yeah.
Okay, yeah. So now that's you. Okay, now you would like to tell us about interoperable microservices with MicroProfile, right?
Yes, I am.
So let's go then. Share your screen, and I'm really curious about your presentation.
Yes. Cool, thank you. So I'll just start sharing here. There we go. So there. I hope you can see this. This presentation about building interoperable microservices with Eclipse MicroProfile. I'm Ivar Grimstad. I'm currently in the US at the California, just north of Sacramento. I'm in a pretty budget motel, but the Wi-Fi seems pretty good, so I hope we'll get through it. So some words about me. I'm a Java champion and an Oracle Groundbreaker ambassador. I'm a member of the executive committee in the JCP, as well as in the Jakarta EE working group. I'm also the EE for JPMC at Eclipse Foundation. Besides that, I'm also active in Apache with the Apache NetBeans, and I'm running a local Java user group in Malmö in Sweden. So I won't be able to see any chats or anything, so just write them, and Adam or Tanya will gather up some questions at the end. So this talk is about MicroProfile, and as you see, the subtitle or the kind of text underneath the logotype here is optimizing enterprise Java. And why would I have MicroProfile here in the JakartaOne Livestream event? Well, they are kind of related to each other, which we'll see in a minute. So MicroProfile is officially called Eclipse MicroProfile, and that is because it is an Eclipse project. And the Eclipse project, you can look at the project page to find the details about it there. I'll also click around in the browser afterwards so we can familiarize us a little bit with it. But what you see here, the mission is about optimizing enterprise Java for microservices. So it's all about microservices and an ecosystem around microservices, and be able to create microservices easy using the technologies we're familiar with from the Java EU or Jakarta EU world. So MicroProfile, the latest version available now is MicroProfile 3.0. It came out this summer. There is a 3.1 release coming up in a month or so, but this is the latest version out there. And as you see, it's a lot of APIs. And the four boxes on the bottom here, CDI, JSON-P, JSON and JSON-B, there are familiar technologies from Java EE. So when they created MicroProfile, they decided that we need the technologies that is a bare minimum for creating a reasonable microservice using Java EE technologies. And CDI gives you everything you need with context dependency injection and kind of the gluing everything together. JSON-P gives you all you need for JSON processing. JSON is the API for RESTful web services. And since we're usually making microservices with REST APIs, this is the technology for that. And JSON-B for JSON binding, so you can bind Java objects to JSON. So these are the Java EE8 technologies that MicroProfile are built upon. On top of these, we have APIs for open tracing, open API, REST client, configuration, fault tolerance, metrics, JSON Web Tokens, and health checks. And I'll go through these APIs in more detail over this presentation, and probably show demos with all of them. So since MicroProfile is a set of APIs, that wouldn't mean anything if it didn't have any implementations. And there are a lot of implementations about MicroProfile. There are more than these, but these are some of them that I've gathered together here. And you can see most big corporations and vendors within the Java EE space is represented here. You have Red Hat with their Thorntail or the Quarkus products. You have IBM with Open Liberty or Web Source Liberty as well. You have Atomic Tribe with Apache Tommy, Payara with their Payara Micro. You have Helidon from Oracle, and a lot of other implementations out there. So it's free to choose whatever implementation you want to have. And also, all of these give you some way of running your services from the command line or a single Java process, like you would expect when you create microservices. And this has been made popular by Spring Boot that came around with creating a main Java file where you can execute your services right in java-jar and then your jar file, and that's how you run it. And this is no different for these. You can also run these applications as package them as WAR files and run them in a container if you want that, or you can just package the container into the jar and run it from the command line, just as this. And all the vendors or products here provide some capabilities of doing this. But as I said, MicroProfile is about the APIs, and the APIs are built up with a specification document that specifies how the technology should work. There is an API artifact that has some interfaces and classes in it, and also some Java docs so you can figure out how to use them. And there is also a test suite called a TCK, or Test Compatibility Kit, so you can verify that the implementation actually does what it's supposed to do. And this is very similar to what's done in the JCP and also in the Jakarta EE, where you have this kind of triage of things. You have the specification, you have the API artifact, you have an implementation, and some test suite to test it. So I'd like to just show you how to get started with Eclipse MicroProfile. And the best way to get started is to navigate to the microprofile.io webpage. And let's do that. So here I'm in my browser. So in the MicroProfile, you can find information here about the latest version and who's involved, and get some resources, some white papers and stuff. You can find all the projects listed in the project tab if you want to read up on the details about the projects. So they're listing here. You can see there are a lot of them. There are samples. There are some of them are included in the platform. Some of them are on the way. You have some support for reactive stuff, reactive messaging that hasn't made it into a kind of collective version of MicroProfile yet, but it's there. And you have some resources, and the most interesting thing for now is the starter. And for those of you who have used the Spring Boot tooling for creating your web services, you're familiar with this. And what you do here is you call your application, give it some Maven coordinates. You select the Java version. Some of them you can actually have support Java 11 and above now, but they've chosen to have Java 8 here. You choose which version of MicroProfile you want to run, and depending on which version you create, you see you get different alternatives. So here you have most of the implementations up there for 1 and 2. As you increase the version numbers, the implementation will be a little bit fewer. A lot of them are supporting 2.2. And the latest version, 3.0, is supported by Thorntail and Open Liberty. Let's just generate the Open Liberty one here. And what you can see here also is that you can get examples generated for you. So if you're creating a application from scratch and you want to write this in your way, you just uncheck these boxes and you won't get the sample code in. But if you're like me now and you just want to look at how it's done, just leave them there and you'll get all the sample code in your project. And it's as simple as downloading the zip and unzipping it. So, and since I didn't trust my internet here, I've done it earlier today, or yesterday actually. So I'll open the Dukes one, which I've have prepared. And what you get in this zip file is 2 services. And the service A has examples for most of the implementations here, and I'll go through them in the context when I go through the APIs themselves. You see, you have for the REST client, the configuration, health check, metrics, for the fault tolerance and security. And also you have a second service, which is more of a helper service, just to be able to test the security stuff. So I'll look at this when we go through the APIs afterwards. Okay. So that was the starter. That's the best way to get started with MicroProfile. So if you're new to MicroProfile and want to take something home from this presentation, this is the slide you should copy, or take a screenshot and do it now, and or download it later. But this is just the link to remember to get started with the MicroProfile. Yeah, so just demo that one. And when we are talking about all these APIs for health checks and configurations and etc., it's very easy to come into the notion of microservice patterns, because all of these are in one way or the other implementing some microservice pattern. And I have a slide here showing how they are related. So we have a list of a lot of microservice patterns, and as you see, the MicroProfile APIs implements these patterns in a as you can see here. So I'll go through these patterns one by one and explain the technologies behind it. And the patterns I'm doing here now is the external configuration, the health check API, the application metrics, circuit breaker, access token, and distributed tracing. So externalized configuration. The problem statement for externalized configuration is how to enable a service to run in multiple environments without modification. And that means that you don't want to rebuild your jar or your application just because you're configuring it with a different data source, for example, when you're moving it through environments. Yeah, you want it to be built once, tested as it is, and just configured through the environments, and then finally go into production. So you actually test the stuff that you are putting out there, and it's only configuration, and it should be retrieved from outside of the service. And the MicroProfile configuration supports this. You get for free with the specification. It requires that you have the support for setting and configuration file, which you can build into your application. So it's suitable for when you have properties that don't change, or properties that you want to set for your local environment. So you can have this properties file in your IDE, and that is how you run it when you run it locally. If you set some build it into a Docker container, for example, and you want to set some environment variables there, you can do that, and these properties will override the things in the properties file. And over this, again, you have the system properties, which you can set in your test environment, for example, in your Kubernetes, or whatever you're running your services in. Set some system properties there, and they will override the environment variables and the application configuration files, which is packaged in your file. So they have the priorities set, and you can also create your own configuration sources, such as if you have some sources that are in some secure environment, or you have them in a database or somewhere else in GitHub or in a text file, you can just implement a pretty simple interface and give it a higher priority than system properties, and it will use that one. And there are also vendors that provide these config sources out of the box for you. So the configuration API for microservices is the one that implements the externalized configuration pattern. So let's look at this. So in the file I downloaded from the starter, you can see there is a config here, and I have a config test controller. And what this one does is that it injects some properties. And you can see that the config property is from the MicroProfile config project. So what you do there is to inject a config property called injected value. They can have different types, and they support strings and strings and ints and arrays and all kinds of properties that you need. This is just a simple string used for example. And you can use this injected value in your application. I'll run this application a little later. And you can also see that in the meta-inf folder, you have the injected value property set here. So this is one that will be picked up unless you override it with a system property or an environment variable. So that's how it's done. You can just inject it. You can also do it programmatically if you want, but since we have CDI, it's no reason not to use it. Then we have the health check API. And the problem statement for this API is how to detect that a running service instance is unable or able to handle requests. And the MicroProfile Health API helps with this. And there you have the health check, which is updated for version 3.0. And I'll show a little bit about what's added there. Let's go back to the code again. And as you'd expect, in the health package, you can find the a service health check that just returns a health check response. And as you notice here, the add health annotation is deprecated. So this sample is actually a little bit outdated. Since in version 3.0, you got some more cooler features here, and I'll show how these looks like. I'll just create a alive. So what I did in here was to create a health check, which is annotated with liveness rather than with health. That means that this one can be used for a liveness probe, and this is very useful in Kubernetes to give the environment the message that, hey, I'm alive, don't kill me. So this should be a fairly quick service. It should just be up and answering very fast when you know that, hey, nothing was wrong, I'm up and running. But just because I'm up and running doesn't necessarily mean that I'm able to handle requests yet. So maybe you shouldn't send me any traffic yet. And to help with that, we have the readiness test. So the readiness health check is to say, give the environment, say, okay, now I'm ready to accept traffic. So if you're in the liveness probe, you just say that, hey, I'm up, don't kill me yet. And for the readiness, you can check that, hey, I have the other services or resources or database connections or whatever you need to be able to accept traffic, or maybe you have to build some caches or something. And this can be a longer running thing before you give a ready signal. So let's try and run this one. And I'll just rebuild it quickly. So wherever you have you can still use the health check, and the health check will combine the liveness and the readiness probes for you. But wherever you're using health check today, you should consider moving it to the liveness probe or the readiness probe when you upgrade to MicroProfile 3.0. So luckily, I did this test this morning because they just shipped a new OpenLibrary runtime, and it has to download that one. But I did this morning, so we don't have to wait for me downloading all this kind of stuff. So it should be ready, up and running pretty soon. Okay, let's just leave it there, and I'll revisit after the next pattern. So the next one we'll look at is application metrics. And the problem statement for application metrics is how to understand the behavior of an application and troubleshoot the problems. And the MicroProfile metrics project helps us with that. And it has been updated for version 3.0. So let's look at if it's built here, yes. So let's start this one. As you see, I started from command line, just run it here. And while it starts up, let's go in and look at how metrics is done in MicroProfile. So here I have a endpoint called metrics. I'm injecting a metric here, which is of type counter, so I can count things. And I'm also using a time annotation, so this request here will be timed. I'm doing some thread sleeps here just to get some statistics in it. And I'm doing, if you call the increment endpoint, it will increment the counter, so we can get that in the metrics. And I also have a gauge here that shows the counter. So it looks like it's up and running. So let's go and look at it. I think it was at 8881. Yes, it's up and running. So let's go to the data. Hello. So it has a hello world endpoint that is up and running. And let's look at the health checks that we looked at earlier. So if we go to health, you'll see that it shows me a liveness check, a readiness check, and the regular health check. So if I only want to have the liveness probe, I can go in to the server source live, and it will give the liveness. So this is kind of the path that you give to the environment to check if your service is live. And to check if it's ready, you go into /ready, and you'll get the readiness test. So, and the metrics endpoint is /metrics. So here you get the Prometheus-based all the metrics you need for monitoring your application, and most of these are of type base or they could be vendor. They could be something else. So if I want to just see the base metrics, I see what's required by the specification. If I want to have the application metrics, which is the one I put into the application, you see that there are no metrics yet because I haven't touched the endpoint. I'll just have to check what it was, metric and timed. So if I go into the localhost 8081 data metric timed, this one was the one that had a thread sleep. So if I go in here and refresh this one, it should be showing, yeah, the application metrics, and you can see the timed requests. That all this is what you get out from just annotating it with @timed. If you want the counter to increment, you can see the counter endpoint is 0 there. What was it? Increment. And I'll just open the increment. So if I go in here, it should say 1. If I hit the refresh a couple of times, you see that it's counting. So this is how you can monitor your application usage using the metrics. What's also useful here is actually not one of the APIs I'm showing today, but it's part of MicroProfile, and that is you get open API specification here. So you can just you don't have to write all these kind of open API YAML files or do any Swagger annotations unless you need to give some extra information here. This is something you get for free. You don't have to annotate anything to get it. With the Open Liberty, you actually get a UI with it as well. So you get all the Swagger here for all the endpoints, and then you can run it directly from the browser. So it's pretty cool. Let's look at the circuit breaker pattern. So the circuit breaker pattern problem statement is how to prevent a network or service failure from cascading to other services. And the circuit breaker is something you know from your home, that if a electric circuit is overloaded, it opens up the circuit so no current is going through it, so to prevent your host from burning down or anything. So a circuit breaker in microservices works the same way. If a service can't handle accept requests, you can have a smooth way of discovering it, so you won't affect the other parts of the service more than necessary. So, and the fault tolerance, among other things, also supports circuit breakers. Let's look at the circuit breaker. That's under the resilient package. And in the resilient controller, we have a lot of cool stuff going on. First of all, it's just a regular JAX REST or REST service. You have the fallback handler that says that if this one, for some reason, this circuit times out in this case, or something else happens, you should have this fallback method. And here it's just a method called that are returning fallback answer due to timeout. And you can see that timeout is set to 500, and you have a thread sleep to 700 just to make sure that it's actually happening. And so if we go into hit the endpoint resilience, is it 1 or 2 else? 1. There you go. With an S, yeah. You go in there, and you see it's going to wait for 500, half a second, 500 milliseconds, and it says fallback answer due to timeout. And that is because it times out after half a second, but it sleeps for 0.7 seconds, and that's why it never gets in there. It gets the fallback handler. So this is a very easy way to showing how the fallback and timeout circuit breaker happens. So, and this could be that this thread sleep is actually you're calling a service that just takes too long. So the access token, that is how to communicate the identity of the requester to the services that handle the request. And in order to explain that one, let's just go through very quickly some simple ways of authentication. And we all know the basic authentication mechanism, which is an authorization header in the request saying basic, and you have your password there. It's hashed, but still, you just send a password or token in your request calling with the basic prefix, and it's sent with every request. For OAuth 2, it's pretty similar. It's just that you send something else in the authorization header. You send bearer and a little bit stronger encrypted, but still a password. And so for the basic authentication, it's basic something, and for OAuth, it's bearer something. It's a bit stronger encrypted, and you have all these ways of refresh tokens and et cetera, but the actual security mechanism is pretty much exactly the same. Then we have the JSON Web Tokens, and JSON Web Tokens are also exactly the same as with OAuth. It's just it's a much longer token, and this is a little bit easier to read if we color code it. So you have the first purple part, which is a header. Then you have the green part, which is the content of the token, and the last part, which is a signature. And let's look at how these are built up. So the header is a JSON object. It's basically for URL encoded, and it gives you information about the algorithm used and the type of token. And then you have the body or payload of the token, which is also JSON, basically for URL encoded. And you have some standard entries that have to be there according to the specification. And you have some custom entries that you can add if you want to add some information that your services can make use of. And then at the end, you have a binary signature, which is the actual signature of the payload and the header. So if somebody tampers with the entries, add a new custom entries or change the role or something, the signature won't be valid anymore. And this is how it will look in clear text if it's just a basics for de-encoded. So in this case, you have the algorithm in the header, and in the green text, you have the type of token, the scopes of it, and you have the expiration, etc. And you have some custom attributes such as username here, for example, and the digital signature, which is produced by the issuer of the token. And the JSON Web Token propagation specification gives you all the infrastructure around it and the API to use this very simply. So let's look at that one. So for the secure service, we have a secure controller. And what we have here is, you see, it's still just a regular JAX REST resource, just the path attributes and stuff. And in this one, we have some code to generate a token. And this would usually be done by a token provider. So this is not something you do very often yourself, but from time to time, you have to generate a token. And you use whatever tooling or technologies you have there to do that. And this one creates a header, the actual token, sets the required attributes here, and can add additional claims such as the custom values or groups that this particular user is part of, and just sign it with your key and return a serialized token. And then I can use a regular REST client to call a service, and here I'm calling the other service that is included in this example, and I just set the authorization header with bearer and get the token string here. And what I'm doing is I'm reading some response out of the call to the service. So look at the other service. The one I'm calling is the one called service B. And here I have the protected controller, which is the one I'm calling. And here I'm just injecting a claim with a custom value. And what I'm doing with it is that when I get a GET request, I check that the role of the caller is protected. And then I return the text saying protected resource, custom claim is custom get value. So I'm using two elements from the token here. In the add roles allowed, I check that the role of the caller is protected. And this is a Java security annotation, so it hooks into Java security. And also pulling out a claim from a custom value from the token and returning it as a text. And as you see, I'm just writing it out here. And when I've built the token, the custom value I set to it was just a specific value. So if I have to just start the second service, there, and then I should be able to call the protected one in the service A. And I think it's called protected test. It's not that. Let's see what it's called. There we got it. It's secured, of course. So I'm generating a token and then I'm calling the other service. Let's see how it works. Okay. Well, everything can't work every time. Okay, it wasn't up and running. Let's see. There you go. Claim value within the JW token was, and this is the text I got from the other service. So see, I'm creating the token in my service A, and I'm propagating it to service B, extracting some value and returning that value and displaying it here. So the last pattern I'll show today is distributed tracing. And that is how to understand the behavioral notation and troubleshoot problems. And a pretty common tool using for that kind of tracing is Zipkin. You can also use Jaeger or other tools supporting that protocol. But Zipkin is one I'll demo here. And this open tracing is supported by the open tracing specification. And let's look at a more end-to-end example. This is a part of a hands-on lab which I've created for MicroProfile, and you're free to download it. I'll show the link to it afterwards. I won't be able to run it today though, because when I tested it earlier, when I set the tokens in my browser, I kind of drop out of the crowdcast streaming, and we don't want that to happen. But I'll go through the code. So what's happening here is that I have a capitalized service running on Pyara Micro, and what it does is to take in a name or a word and capitalize the first letter. So if you handle in a lowercase Duke here, it will return Duke with this capital D. Then I have a birthday service that calculates a birthday. So if you add as a date parameter the birthday of Duke, I think it's May 23rd, 1995. It will calculate how many days it is left until Duke's next birthday and how many days it was since his birthday. And it will also return his age, and it will return his name, which has a capital D, even though I supplied her with a lowercase d. And that's because it calls the capitalized service to get the capitalized Duke. So the birthday service calls the capitalized service. And for the first service, I have a hello service that calls with name is Duke and prints the text and extracts the information from what it gets from a virtual service. And the virtual service runs on Thorntail, and the hello service runs on Open Liberty. And the token that is received by the hello service is propagated to the virtual service and then propagated further on to the capitalized service, so you can follow it several steps. But as I said, unfortunately, I won't be able to run it since I'm using a token as input to the hello service, and it will kill the broadcast. But we'll look at the code. So let's first look at the capitalized service. And the actual service is super simple. It just takes uppercase to the first letter. But what's interesting here is that it has the at roles allowed attributes and says that, hey, you need to be protected. So it won't allow anything in there unless it's protected. And it's also set up that the protected role is declared, and it's using the MicroProfile JWT as authentication method. The virtual service is set up similar. So have the virtual resource. It also has the roles allowed protected, and also has the MicroProfile JWT authentication method and the protected role. But also here is that it has some configuration where it says to the MicroProfile REST client, propagate headers authorization. So this property here tells the REST client to propagate the JSON Web Token or the authorization header that contains the JSON Web Tokens to the next client. And that's the way it is propagated from one service to the other. And here I'm using the MicroProfile REST client to do the call to the capitalized service. So I'm injecting here a capitalized service, and the capitalized service is just an interface with the JSON annotations. It says at path capitalized, and it has the at register REST client, so it will generate a proxy that does the actual call to you, and also has the register client headers that says that, hey, add whatever headers that I get from the client that are mentioned in the propagation configuration. And it says that it takes a word in, and it has a fallback method. So here I'm using the circuit breaker also. So call the method as is and just return the word lowercase unless the service isn't calling. It's not been running. And in the config properties, I also say that the endpoint URL for the capitalized service is here, and that's picked up by the REST client. So it's a pretty cool, easy way of propagating all the security information to the next service. And I'm doing the same thing in the hello controller, where I also have some tracing enabled. I'm doing some injections here, and I have a virtual service which is set up the same way as the capitalized service. It's just a interface with the register REST client and client headers annotations. It also has some fallbacks and some retries unless the service is up and running. So it'll try it 30 times before it gives up, and then returns just -1 for the properties. And it also has the configuration for propagate the authorization headers, and it has the URL for the birthday service. So, and if I run this service, I also have Zipkin running on my local computer. So I ran it earlier this morning. So if I go in here and say find traces, you can see that the let's see. Well, it doesn't show anything. Okay. So if if I run this service, it would show the based on the tracing annotation that I have here. It will trace the hello service. You can also do that programmatically, which I've done in the capitalize service. No, in the birthday service. Where are we? There we go. Here, I'm doing some programmatic tracing. So I see that I'm calling it capitalize. So you can actually trace service calls, even though the actual class there or the service there hasn't any configuration for tracing at all. As long as if I'm tracing this one, I can add the scope for tracing the capitalized service, even though I don't have any tracing there. So to sum up, the MicroProfile implements a lot of the important patterns useful for microservices. And it's very easy to get up and running. And if you're used to using Spring Boot, for example, for microservices, you'll find this very familiar and probably a little easier because it's less configuration. It's just there. It's just super intuitive to get started with. Try out the examples on the starter page and just play around with it, and you'll see how easy it is to take all the code I'm showing here today. I've been using different vendors implementations, and all of it is portable. You can move it across services, across the implementation from the vendors in any way you want. And also, since MicroProfile and JakartaOne is parts of the Eclipse Foundation, Kevin mentioned in his talk earlier today that there will be, and there are synergies. There are the same people working in both these communities, and I usually stress that it's JakartaOne and MicroProfile. It's not versus, or it's not two sorts of technologies. MicroProfile builds upon JakartaOne, and after a while, we will start thinking of how are we going to make this more clearer, and how are these two projects going to coexist together, and how are they going to benefit from each other, because there are so much to gain from some of the projects in MicroProfile would be very useful to maybe have in some kind of base JakartaOne package, or vice versa. So the patterns I'm talking about today, you can find them on microservices.io. I have lots of samples on my GitHub. Feel free to contact me on Twitter or GitHub or anywhere else if you want to have some questions or something. Microprofile.io is the place to start with MicroProfile, and especially the starter. I recommend just download the zip file there and look at the code, run it, and see how it works. And the Jakarta.ee is the site to find information about JakartaOne. So that was what I had. Thank you for listening, and I'll just stop sharing my screen and go back to and see if there are any questions or something.
Okay, I'm sure there are questions, and thank you for this amazing session. So let's see, the questions, you can pull out the questions from the Ask the Question at the bottom
Okay, so
of the
you're
line, but I
breaking
can
up a
also
little.
read it for you if you want.
Yeah, you're breaking up a little.
Okay, is this better now? Okay, can you hear me here?
You're breaking up, so I can't hear you, but I see there are 4 questions here in the, it says, I'll just read them up and answer them. So it says, without JPA as part of the project, how do most MicroProfile applications handle persistence? Is there any preference to use JDBC or import your own persistent provider into the application? Well, I think it's probably up to the project itself. So I'd like to do it as simple as possible. So I usually use JPA or maybe Hibernate. If you're using the Quarkus product, for example, I'll look at Apache or the Panache that generates stuff for you, similar to Spring Data. Or you can write your own JDBC, but it's more or less up to the projects. If you're using NoSQL, look at the Jakarta NoSQL projects and see if something there can be used. So it's not specified by MicroProfile, but all these products are built on top of Java EE and Jakarta EE technologies. So if you're running, for example, Open Liberty, and it supports the full Jakarta EE profile. So you have all the technologies there available for you. And that's the same with Thorntail and Pyara and the others as well. So it's just whatever is there. So how can you unit test this, the REST client config and stuff? I guess it's the same way you would test any REST service. MicroProfile doesn't provide any infrastructure for testing yet. That is a question. That is a dialogue I've had with the Spring community, because Spring brings a lot of good support for testing. In Java EE, Jakarta EE, MicroProfile, we've chosen to kind of keep it out of it. So you can use any environment around it, like Achillean or something. So it's basically the way you do testing today. Is there any implementation plan for the outbox pattern in MicroProfile? I'm not sure. You just have to check the mailing list. And can you provide a few examples when should I use Jakarta EE instead of MicroProfile and vice versa? I would say use both. It's whatever you need for technologies, do it. So you can use MicroProfile with Jakarta EE. So if you have a Jakarta EE application and you want to have health checks, just use health checks with Jakarta EE. Is it possible that specifications diverge under Jakarta EE versus MicroProfile? I would say no, because it's the same people there, and that should we will make sure that don't happen, because that will be taken care of by we're sensible people. I think I don't think that's going to be a problem. And then Reza has a question here. What's your new role at the Eclipse Foundation? So as of October 1st, I will start as the Jakarta EE developer advocate at Eclipse Foundation. So that will be my new role there. And I hope to be out there meeting a lot of you at conferences and meetups like this one, and talk about all this stuff about Jakarta EE, MicroProfile, microservices, enterprise Java, cloud native stuff, everything about this. So yeah, I guess I think I got them all.
Thank you, Ivar. I hope my voice is coming through now loud and clear. If it's not,
It is.
It is? Okay, fantastic. So
and I see we have more than 1,000 people listening to us.
I know, look at that. It's amazing. Thanks everyone for joining and registering for this amazing session and marking this day, because it's pretty big in Jakarta EE community. And at this point, we will give you a few minutes of a break, and then we'll join you on our next session with Adam Bean, and I will see you all there. Thank you so much.
Thank you.